This video is about partial sums of a sequence. For our note, let's start by defining this in the following way. For a sequence defined with the subscript notation, so like a sub 1, a sub 2, a sub 3, and so on, the partial sums are as follows. We could say that s sub 1, so now notice we're using a capital S with some kind of subscript, and so s sub 1 would be the sum of the first term. Well, notice s sub 2 is the sum of the first two terms. Okay, s sub 3 is the sum of the first three terms. Okay, you get the idea, right? S sub 4 is the sum of the first four terms, all the way down to really any number of terms. So s sub n would be the sum of the first n terms, whatever n might be. S sub 1 is called the first partial sum, S sub 2 is called the second, of course S sub n is called the nth partial sum, and then the sequence S sub 1, S sub 2, S sub 3, all the way up to S sub n is called the sequence of partial sums. Now this is different than the sequence from which we're getting these partial sums. You'll notice in this definition here that the sequence started as a sub 1, a sub 2, a sub 3. Those a's are the terms of the sequence. When you start adding them up, that's when you get the partial sums. So the S notation is for these sums. Let's try an example where we want to find the first four partial sums and the nth partial sum of the following sequence. Now the sequence is defined as a sub n equals 1 over n plus 1 minus 1 over n plus 2. So it's a difference of two fractions here. Now we want to find the first four partial sums, and so given the definition we have above, let's go ahead and start writing these out. We'll write the first one as s sub 1, that's the notation we have above, and you'll recall above that this really is just the first term, and there really isn't anything else to add with it. Well, given the way this sequence is defined, that would be like a sub 1. Well, that's really 1 over 1 plus 1 minus 1 over 1 plus 2. That's just the first term. Now let's summarize that a little bit neater. That's really 1 over 2 minus 1 over 3. Okay, we're just simplifying those denominators there. All right, but that's just the first term, and that's pretty boring, but that's the first partial sum. Now the second partial sum we'll write out as s sub 2. This would be really the first term, which we can just kind of copy over. We already found it in the previous step. So I'm going to just write that, but I'm going to put it in some parentheses just to bundle it up and stay organized. It was really 1/2 minus 1/3. That's the first term, but now I'm going to add the second term with it. Now we'll put this one in parentheses as well. The second term would be when n is 2, so I can take my definition above for a sub n and plug now where n is 2, that would be 1/3 minus 1/4. Okay, so now I'm adding the first term and the second term together. That's for the second partial sum. Let's keep going. Remember, we want all the way up to the first four of these. The third one will be, well, what we already had, so I'm just going to recopy that again. So that was 1/2 minus 1/3 plus, the second one was 1/3 minus 1/4. But now we're going to add the third term. Again, I'll put this in parentheses just to stay organized with it. The third term is plugging n as 3 in this original definition. That would be 1/4 minus 1/5. Okay, so you're starting to see how this goes. Now let's keep writing them out and see if we can observe a pattern here. The fourth partial sum would be all of this plus one more. So let's copy this down. We have 1/2 minus 1/3 plus 1/3 minus 1/4 plus 1/4 minus 1/5 plus, okay, that was the first three terms now, but for s sub 4, I want the fourth term as well. So I'm going to add that one on here. That's when n is 4. So defined in this original definition for a sub n, when n is 4, I have 1 over 5 minus 1 over 6. Okay, now that's the first four partial sums, and no, those are not simplified, but the arithmetic involved in combining all those fractions isn't really where our focus is right now. A calculator could easily do that. We rather would like to focus next on this nth partial sum. We're looking at a large string of sums, but notice what's happening. If we back up just for a second to s sub 2, if you look at the way we wrote that out, there was a minus 1/3 in the first parentheses, but then there was a plus 1/3 that would follow it. Wouldn't those just cancel out if we were combining all of these? Right? So we're not actually going to combine them by hand, but really those terms would cancel out. Well, if you go to s sub 3, the same thing happens, right? The minus 1/3 and plus sub 1/3, those would cancel out. But now move on to the right and notice the same thing would happen with the minus 1/4 and plus 1/4. Those would cancel out. Okay, moving on to s sub 4 that we've already written out, notice the same thing keeps happening, of course, because we keep rewriting all these terms. So the minus 1/3 and the plus 1/3 would cancel there. The minus 1/4 and plus 1/4 would cancel next. But now moving on, the minus 1/5 and plus 1/5 would cancel in the same way. Okay, now just think about this for a second. I've only written out the first 4 partial sums. Wouldn't this keep happening if we kept going? So notice what's happening though. We still get this 1/2 that's written as the first term in all these partial sums. So that 1/2 kind of stays the same, and it would continue to do so. But notice the last term is changing. If you go back to the s sub 1 first partial sum, that last term was a minus 1/3. In s sub 2, it was a minus 1/4. In s sub 3, it was a minus 1/5. And in s sub 4, it was a minus 1/6. Okay, so that's what's interesting. If we're going to have to define an nth term or an nth partial sum definition, we have to focus on what's changing as the index or the n value keeps incrementing. It seems like it's not the first term in these sums. Those are simply 1/2 every time. It's this last term that after everything in the middle is canceled out remains. So let's see if we can define an s sub n definition. Of course, it's going to start with a 1/2. The question is what comes after it? Well, you'll notice at the end, all these terms are all being subtracted. So let's try a minus. And then notice all their numerators are just 1. So we'll put a 1 over something. Now, let's take a careful look at how the denominators of all these last terms relate to all the n values for these s subscripts. You'll notice, after looking probably not too carefully, that they're just 2 numbers higher. So like s sub 1 ends with a 1/3, s sub 2 ends with a 1/4, s sub 3 ends with a 1/5. So if we simply add 2 to the index, we seem to get the denominator in that last term, which means I should be able to write an n plus 2 as how to define that denominator of the second fraction, which means this should fit as our nth term definition. It's 1/2 minus 1 over n plus 2. Now that probably would not have been obvious if we had not written out all this cluttery detail here and seen how things start to cancel out. Writing it all out really did make it evident that this should work for our nth partial sum definition.